Hi, everybody. This time we are going to talk about density. Now, density is something that I am pretty sure you have an intuitive understanding of, because if I asked you to list some objects that had low density, I'm sure you could come up with things like styrofoam and bubbles, clouds, styrofoam packing peanuts, things that were lightweight when you picked them up. High density objects include things like bricks of gold, which most of us don't pick up on a daily basis, but you understand there's a lot of stuff in every small amount of space. Bricks, lead, some things are just packed really tight. And that's that idea of density. There's a very specific scientific definition of density, and density is defined as the amount of mass per unit volume. It literally is in an amount of space how many molecules are packed and how tightly packed those molecules are in a particular quantity of space. Now, scientists actually mathematically can calculate the density of a material. Density is calculated by looking at the mass of an object divided by the volume that it occupies, where D represents density, and density can be measured in grams per cubic centimeter. And since 1 cubic centimeter is the same quantity of volume as 1 milliliter, sometimes you will see density also measured in grams per milliliter. Mass in chemistry is also measured in grams, and volume can be cubic centimeters or milliliters because those two are equivalent. This is a density chart that you are going to need to refer to as you do homework problems. And in the next video, we're actually going to do some mathematical calculations of density. But this time, we're just going to talk about density as a property. And if you look at this chart of densities, you can kind of see the numbers that accompany what you intuitively know. Things like silver, lead, gold, these metals are relatively heavy compared to the amount of space they take up. We've all seen movies where people are stealing gold and it's really, really heavy per brick. Well, that's a property of their density. You get into things like fluids, olive oil, alcohol, gasoline. These are low densities compared to other fluids like water, milk. Mercury, which is a fluid, fortunately, we do not encounter very much anymore because of its chemical dangers, but it's a very high density fluid. And gases, very, very low density, leading to the fact that they have a tendency to float or to rise above other things. Density is a physical property. Earlier in the course, we talked about physical properties and we also talked about chemical properties. Chemical properties, if you remember, are how one substance or chemical reacts with another thing. A physical property is a property of a substance alone, all by itself. And density is one of those pieces of information about any chemical or compound that we can use to help identify it. Back in the gold rushes of California and Alaska and the Dakotas and different parts of the world, there used to always be an assay office, and there were basically chemists that worked there, and the miners would bring in their samples of gold, and a density test was one of multiple tests to determine the purity of their gold ore and determine how valuable their find was. Water. Water covers 3/4 of our planet. The metric system is based on the number 10 and the compound water. And the beautiful thing about using water so often is that the numbers for water are very convenient. The density of water in grams per cubic centimeter and grams per milliliter is 1. So in common chemical experiments, in common situations, the density of water is going to be 1 gram per cubic centimeter or 1 gram per milliliter. If you are dealing with larger volumes, larger samples, it's going to be 1 kilogram per liter. And why do I mention at 4 degrees Celsius? This is an important temperature in chemistry as we start talking about changes of state when something going from a solid to a liquid to a gas, and we start talking about latent heats and things like that. We'll get into that in more detail, but those numbers are important. Put a little star by them. Make sure you have those down someplace because we're going to use those. Now, density of water does change with temperature. And this is one of the examples that I have noticed in my lifetime. I live in Wisconsin, and we periodically swim in ponds and small lakes. And you go swimming early in the summer because it's been a long, cold winter, and you want to jump in because you just need to jump in. Well, the water gets heated by the sun in those little ponds and lakes, and in May, there's not been a lot of time for the water to heat up. And warm water has a tendency to be less dense than cold water. That cold water is more dense and it's further below. So you jump in that pond in May for Memorial Day, and your poor little body tries to swim and float in this top little layer of warm water up there, and you freeze your little body. It's cold in those lakes that just are snow melt. By August, or by time Labor Day rolls around in late summer, the ponds have had all summer for that hot sun to warm up the water. The warm water is on the top. The cold, more dense water is down below. The warm, less dense water is on top. And you have this big, beautiful layer of lake water to swim in. And it's much more pleasant swimming in those lakes on Labor Day than it ever was in May. But that is a good example of that density temperature change. We look at floating and sinking. That's a real important thing when we talk about water. Anything that floats in water is going to have a density that is less than 1 gram per cubic centimeter. So everything from logs that were that were floated down the river to sawmills in the old lumber years, or rubber duckies, they all have densities less than 1. Anything that is going to sink in water is going to have a density more than 1. So boulders and rocks and sand and pebbles are all going to have densities more than 1. I don't know how many of you have ever scuba dived or spent time underwater, but divers very often are going to have lead weights that they add to their body to give them the proper density so they can go where they want to go in the water. So here, let's look at this situation. This is a classic chemistry demo. If we weren't doing this online, this is often done in a chemistry class. And that is take a large beaker or a large vessel, fill it full of water, and put in a diet soda and a regular soda and see what happens. And it's a fascinating thing to look at. The diet soda tends to float and the sugared soda tends to sink, of the same brand. What's going on here? Well, what's going on is the soda pop contains carbon dioxide that is mixed in with the water molecules, and it has a tendency to make there's gas mixed in, so makes the diet pop less dense than water, and it has a tendency to float. So what the heck is going on with the full octane pop that makes it sink? Well, full octane pop contains sugar, and sugar molecules, this is a picture of a sugar molecule. Sugar molecules are big beasts. C12H22O11 is a sucrose molecule, big beast molecule. There's a lot of sugar in there, makes this fluid high in density, and so the sugared pop has a tendency to sink. The diet pop, because it doesn't contain these big fat sugar molecules, has a tendency to float. It's a great little demonstration of how chemistry can be seen in density. Now, the average density of people is just under 1. So if it's just under 1 gram per milliliter, do humans have a tendency to sink or to float? Well, in order to float, you have to have a density that is less than water. So most of us in water, if we just relax and let go, most of us are going to float. That is unless you are very, very lean. My husband, when he was very, very young, he can't do it anymore. He was a cowboy and he rode rodeo and he was a skinny little thing. For giggles, he would annoy people. He would go sit on the bottom of the swimming pool because he was all muscles and he would just sit there. I mean, not for long. He'd lose his breath after a while. But because he was so lean and he had almost no body fat when he was 18 years old, he could sit on the bottom of the pool. As we get older, we have a tendency to accumulate more fat. That's just biology. And we have a tendency to be more buoyant. And fat floats. Is that good or bad? Let's pretend it's good. It's good. It's a very good thing. Specific gravity is another term you're going to hear, and you're going to hear the term in relationship to density. Now, here's the definition of specific gravity, and you know I ask you definitions on quizzes, so make sure you've got that highlighted. Specific gravity is the ratio of the density of a substance compared to the density of water. There's no units on specific gravity, and the term is used often when we're looking at liquids. So if I want to know the specific gravity of ethyl alcohol has a density of 0.785. So the specific gravity of ethyl alcohol is going to be 0.785 grams per milliliter divided by the density of water, which is 1 grams per milliliter. Now the units are going to cancel. And this number, anything divided by 1 is just that number, so it's 0.785. It's a unitless number because of the fact that it is a ratio. If you want to know the specific gravity of any substance, you basically just read it off the chart. So what's the specific gravity of silver? Well, for silver, it's going to be 10.5. For aluminum, it's going to be 2.7. It is a shorthand way of expressing density, but it's compared to water. And why do we care? Because we care so much about sinking and floating. Here's a question if you really understand this density. If you were going to make a mixed drink, let's say you wanted to make a rum and Coke, which one would you add first? Ethanol with a specific gravity of 0.785, or the mix, which has a density of a little over 1. Which one would you put in if you were lazy and didn't want it to have to mix it up? Well, I would put in the alcohol first, because if you put the alcohol in first with 0.785 and then you put the mix on top with a density of 1, it will self-mix. The mix is going to go down, the alcohol is going to come up, and it will self-mix. You won't have to mix your own drink. And that's kind of nice. There's a device you're going to encounter once in a while, and it's called a hydrometer. And a hydrometer is a gizmo that you basically float in a long tube or cylinder, and it has numbers on the side, and you just read those numbers and it'll tell you the specific gravity of a fluid. It's commonly used to test the specific gravity of urine when you go to the doctor and they want to analyze your urine. It's used in auto garages to test the specific gravity of radiator fluid, battery fluid. It might look like this, and they can suck up the battery fluid, and by looking at the battery fluid, determine if the battery is good or bad. It is a quick way of measuring specific gravity, and by that method, determine the density of the liquid they're looking at. Okay, next time we're going to come back and we are going to do some math with